E. Okay, guys. Today, remember that we will continue working with the SQL assignment that is called the SQL Bolt assignment. Okay, and I will give a small lesson at the end of the class. So remember, we're going to divide the class again into parts. The first part of the class is where you can continue practicing with the SQL joins, and in the second part, I will be explaining um, again, SQL joins with a different example. Today I have an example prepared for a hospital and some patients, doctors, and appointments. And there are some reporting questions that we are going to be solving too. Um, so you are welcome if you need some help with the assignments. Let me know if you are having troubles with one of the lessons in the SQL Vault assignment. um, I could help you. For example, what I did with that last week with Raylon, I was solving the lesson with her. And if you feel that you need my help to solve one of those problems, I am glad to be your help. Okay. So be my guest, start working, and let me know if you need any support. The second part, remember, we're going to have a small lesson. Okay. Are you there? Can you give me your attention, please? Everybody.
I'm here.
Okay. Well, the lesson for today is that we will continue talking about SQL joins, okay? And today in this class, we're going to talk again. I mean, it's not talk about it, but it's like reinforcing the topic, okay? And there is something that is called Venn diagrams. I will give you like an idea of what is this. It's something we learn it in math too, and it's very. I mean, the Venn diagrams is used if you want to represent sets too. Okay, so they are a graphical way to represent a set too. Okay, so the objectives for today are the next ones. We're going to understand the concept again of a set and their operations, union, intersections, and difference. Learn how Venn diagrams visually explain SQL joins. We're going to understand the difference between an inner join, left join, right join, and full outer join. I have been explaining these joins, and but if there is something that is not understood, this is going to be repeated today. And we're going to write some SQL joins queries to solve some practical examples. So first, the first topic, remember a set is very similar to a table, and we have some operations that we can do inside of several sets. So in this case, what I'm going to do is that I'm going to pause the recording. I will leave this part of the sets problems. And I know that you know what is a set. Okay, so I have the set A and the set B in this slide. And there are some operations. Uh, no. I mean, this is the definition of it. Sorry, I have an example for later. But okay, let's explain what is a set. So I told you that a set is a collection of unique elements. Okay, and in this case, we have the set A and we have the set B. We have the content of the set A is 1, 2, 3, and the set B, the content is 3, 4, and 5. And we can do some basic operations here. We have the operation of union and we have the operation of intersection. The union operation is going to combine all the elements with both sets. But in this case, we're going to avoid having a number that is going to be repeated or an element. We're going to avoid repeated elements. And the union, as you see, is 1, 2, 3, 4, and 5. Do you remember this? If you don't have access to your microphone, you can put a message in the Zoom chat. Great, great. Now, we have the other operation that is called the intersection. And the intersection is going to bring on only the common elements that we have in a set. And in this case, the operation of intersection with the set A and B It's the number 3 because it's the only number that we have in common between the two sets. And if you don't remember, this operation is equivalent to an operation in a join that is called inner join. Okay, because the inner join is going to bring the elements that are going to do a match between the two tables. Okay, so we have the inner join and it's equivalent to an intersection. Now, the union that we have here, it's another SQL operation that is called the full outer join. Or full join. This is going to bring all the elements that you have combined in the result of the join. So let's continue. Let's see. Let's go for the next slide. So what is a Venn, or what are Venn diagrams? A Venn diagram is going to help you to visualize how do we represent the sets and their relationships. In this case, this circle that you see here, this is representing one set, and the other circle is representing another set. But as you see, they have some elements that are in common, right? We have this small part of the circle, of both circles, that they are in common. So this operation or this diagram is representing an intersection. And this part that is the same is the result table or the result information about a query. Okay, the circles are representing, as I told you, the sets, and the overlapping areas of it's going to show the relationship between the two sets. So in this case, this part is the intersection. Does this make sense? Everybody?
Yes, it does.
Okay, great. Now, this part, this is the practical part. I have 3 sets here. What I'm going to do is that I'm going to pause the recording and I will give you 5 minutes so you can try to solve these exercises by yourself. Okay, so the idea is that you can find the intersection between A and B. Then let's see. No, the union. Sorry, this is not the intersection. This is the union. Then you're going to find the intersection between A and B, A and C as union, intersection A and C, and so on. The idea is that this is like the most difficult operation. The 2 last operations are the most difficult ones. And I will be selecting some of you guys that you can give me the answers. Okay, so I will pause the recording, try to solve these operations by yourself right now. Okay, let's try to solve these problems right now. Let me see, I'm gonna start. Okay, let's try to find the first answer. The intersection between A and B. So in the intersection, we only have the ones that are in common. So between A and B, the numbers that are in common are the number 4 here, number 5, number 6. Do you agree? So the answer would be a new set that will contain the number 4, 5, and 6. Now,
But that says union.
yeah, can you repeat?
That says union. Find a union between A
Oh,
and
sorry. Yeah, thank you. My
B.
mistake. Yeah, thanks. Sorry. My mistake. Again, here we have a union, so we need to, yeah, we need to make a new set that's going to contain all the elements without no repeat numbers. So the union will be, give me a second. I'm gonna put it here. Okay. So we have the number 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, this is the union. Now let's try to go for the intersection. This is the second exercise. So here we're going to select the ones that are in common. The ones that are in common are the number 4, 5, and 6. So the answer for the second exercise will be another set that will contain the three numbers 4, 5, and 6. Now let's find the union between, let's see, let me erase some elements here. Great, now let's try to find the union between A and C. Okay, the union between A and C will be, let's see, 1, 2, 3, 4, 5, and 6, 8, and 10, okay? Eight and 10. Now, let's find the intersection between A and C. The intersection will be the ones that we have in common are 4 and 2, and the number 16. So there are three numbers here in common, 2, 4, and 6. Three numbers in common. Do you agree?
Yes.
Great. Now let's find the union between B and C. The union between B and C will be, let's see, 2, 4, 2, 4. So this is it's 2, 4, 5, 6, 7, 8, 9, and 10. Do you agree?
Yes.
Great. Now let's find the intersection between B and C. So the ones that we have in common are 4, 6, just 4 and 6. Now, this is the most difficult one. We have to do first an intersection between A and B. So which is gonna, I mean, what's gonna be the intersection between A and C? I mean, no, it's a union between A and B. I think we have the intersection, I mean, the union here. It's all
Shouldn't
this,
the 8 be also part of the 4 and the 6 for the last one,
um,
B and
this
C?
one.
Or
You're, I mean,
that,
can you repeat, please?
You said only 4 and 6. Is it not 8 also?
because it's common with them too.
Yes.
Okay.
Let's try to do it again. I mean, it's for the intersection between B and C, right?
Correct.
I missed that one. Yeah. 2, I mean, 4, 4, 6, and 8. Yeah, thank you, thank you. You are in class. Thank you, thank you. Okay, now let's try to do this operation. In this operation first, we need to do the union between A and B, and then we need to do an intersection with C. And we have this operation in this, I mean, this is the answer of the union of A and B, right? 1, 2, 3, 4, 5, 6, 8, and 9. Do you agree with that?
Yes.
Yeah. Now, to this result, we're going to do an intersection with the C that we have here. And the interception is going to be 2, 4, 6, and 8. Do you agree?
Yes.
So the answer of the last one, I mean of this one, this is not the last one, will be 2, 4, 6, and 8. Great. Now, we need to find the interception first between A and B. The interception between A and B is this one, 4, 5, and 6. Do you agree?
Yes.
Now, this is going to be the first set, and we need to do a union with the letter C. So we have 2, 4, 5, 6, 8, and 10. That's going to be the last answer. 2, 4, 5, 6, 8, and 10. And this is the last answer of these operations. Okay, let's go to the next slide. Okay, so how inner joins are going to be related with Venn diagrams. Joins allow us to combine data from multiple tables. And we are doing this because we have some columns that we have relationships between the tables, okay? And if we don't have those columns, we won't be able to create a connection. And the first join that we are going to learn is the inner join. The inner join is going to do an intersection between two tables. So it's very similar to this operation, this one, the intersection. They're going to bring only the ones that you have in common. Now, the left join, you're going to bring all the data from the left table. Remember that when you read a query, you're going to read from the left to the right. Okay, so you're going to bring all the elements of the table, the left table, plus at the same time, you're going to bring the intersection elements. Okay, now the right join, you're going to bring all the elements of the right table, and plus you're going to bring the intersection elements too. Now there is another union that is called full outer join. I don't think this is a very practical join. It's not so common that you're going to do this kind of operation in a database, but this is going to bring all the data between the two tables. Okay, so if you have some elements that are going to be intercepted there, yeah, you're going to bring them, but you're going to have repeated records. And I mean, this kind of join, as I told you, is not so common, but it could be that someday someone can request that kind of information. Now, how we represent the intersection with a Venn diagram. So as you see, the set A is this one, and this is the set B. The intersection between A and B is this common part that we have here. And it's very equivalent in this case to this join that we have in this case for this SQL element. We have the table of enrollments and we have the table of students. And as you see here, we need to do an inner join to identify how many students are enrolled in classes. Do you agree with that? I mean, we can have like 1,000 students in the table of students, but not all the students are going to have an enrollment. So if you want to bring the ones that are in common, you need to do an inner join. Now, the left join. In this case, remember, we're using the table of students and the enrollment table. Again, we have those examples previously talked about, and we have this join that is called the left join. The left join is going to return all the rows that you have in the left table. Now, I told you that we need to read the query from the left to the right. So the left table is the student table. So if you have 1,000 students in this table, you're going to bring those records in the result. And at the same time, you're going to bring the one that are in common. So we have the entire A table or the students table and the ones that we have in common in this operation. This is the difference between having an inner join and a left join. Now, the left join and the right join, they are very similar. But in this case, you're going to bring all the elements that are in the right table. In this case, the right table is the enrollment table, because remember that we read the query from the left to the right. So you're going to bring the ones that are in common in this part of the operation, yeah, but at the same time, you are going to bring all the elements from the right table. So that's, I mean, it's not the same as the left join because you're going to bring the elements of the opposite table. Does this make sense? Students, does this make sense? Please, if you give me a feedback.
Yes.
Yeah, okay, great. Now let's talk for the last okay, the full outer join. This is the last one. It's not so common, but if you do this operation in the SQL query, you're going to bring all the elements from both tables. As you see, doesn't matter if you're going to do a match between them. Um, that's not so common to do an operation that is not so common, but you can bring all the elements from both tables. Now, there is an example that I have prepared for you, and this is an example about you being a database administrator for a hospital. The hospital is going to track the patients, the doctors, the departments, and the appointments. Okay, and this is the data definition that I have for you right now. So we have the table of patients. As you see, we have the primary key that is um, an auto increment. Now we have the department table. This department table is going to be a parent table for the doctor, because as you see in this table definition, the doctor is going to be part of a department. Does this make sense? That we have the parent table department for the doctor, because you cannot have a doctor without having a department first, because we have this foreign key, and it's a relationship one to many. One department is going to contain several doctors or many doctors. Okay. Now the patient is a parent table by itself. Now we have the table of appointments. In this case, we're going to set up the appointment is going to be a relationship between the doctors and the patients. As you know, you can have I mean, you could be a patient in a hospital, and you know that you can have several appointments. Those several appointments can be attended by several doctors. So that's a relationship many to many. Okay, and uh, this appointment table is going to be the bridge table between the patients and the doctors. So as you see, we have the appointment ID, we have the patient ID because this is referencing the primary key of the patient, and then we have the doctor ID that we have the reference to the doctor. So as you see, as I told you, these kind of relationships, they are many to many. And we have this bridge table. In this case, this is called the appointment. And in the appointment, we are going to have the date and the reason of the appointment. Does this make sense for this data analyze that we're going to do? I mean, this is a data practical part. Now we're going to insert some data, but first, previously to start inserting data, I will be creating the tables with you. So this is something a little bit different that I'm going to explain here in my database. So as you see, you have your connection here, and you see this schema that is called security. The second schema is called, this is the database security, sorry. The database of security, the database that is called Postgres, and there is another database that is called RDS admin. We don't have access to this database. But this is the database that we have in our project. And inside of the database, we can have something that is called a schema. This is the default schema that is created when you create a database. And this schema is the public schema. As you see here, we have some tables that we have been creating based on previous exercise. But what is going to happen if you want to group your tables in a different exercise? So what you need to do is that you need to create a new schema. So first, you need to select the database that where you're going to create the new schema. In this case, the schema is going to be called hospital, because this is representing the exercise of the hospital. So we're going to click here, and as you see, a statement is added to a SQL file here. And as you see, we have the let's create a schema SQL command. Now we're going to put a name to the schema. In this case, it's going to be called hospital. Now, if we refresh the database, this database, guys, now it's going to contain two schemas, the public schema and the hospital schema. Does this make sense, this part? Now, in this schema, I'm going to start creating the definition of the tables. So let me remove this. And in the query sections, I will create a new query. And this is going to be the query for the hospital. Now, in this query, I think that you can do a connection. Let me see. Mhm. No, let me remove this one. Sorry. I will remove the query. So here, I will create the query here because it's a new query here. Okay, so um, that query is going to be inside of the schema. So I will create it here. Hospital practice. Okay, so first we need to create the tables. So we have the tables inside of the slides. And this is the first table, the table of patients. And I'm going to add the serial data type. So this is going to set up that this integer is going to be auto incremented. Then we have the name of the patient and the birth date. So let me run the query. Client hasn't. What's going on here? I cannot create a query here. Client has encountered a connection error and it's not queryable. Let me see. Let me create a new query here. Let me copy again. Let me run it. Hmm. Hmm. Something is weird in the database. Okay, so I have the table of patients. Something was weird, very weird with my connection. Okay, so let's continue with the next table. Now let me create the second table. This is the department table. This is a parent record for the doctors. So we have the department ID and the department name. This is going to be a serial data type. Great. Now, as you see, I have the table of department. And as you see, everything is inside of the hospital. You see it. Okay, let's continue with the next table. The next table will be the doctor's table. Now, in the doctor's table, we have a reference. So this is a foreign key for the table of department. Okay. Now we have the department table here and the doctor table and the patients. Let's go and create the appointment tables. Give me a second, guys. Give me a second. Sorry. Okay, now let me create the appointment table. And as you see in the appointment table, we have two foreign keys. Mhm. Oh, for the doctors, I didn't set up that this was a serial data type. Let me drop the table of doctors. Hmm. Okay, now let me create the table of doctors. And this is the table of appointments. This will be a serial data type. So we have a foreign key between the patients and the doctors. Okay, now let's check the tables here in the hospital schema. And as you see, we have the patients table the doctor's table, the department table, and the appointment table. Remember, the appointment is part of the relationship many to many between patients and doctors, because we can, as patients, we can have several appointments, and those appointments can be conducted by several doctors. Okay, so that's a relationship many to many. Now, let's create some data, and I have uh, some insertions for you prepared. So let me explain this insertion. First, we're going to start filling the table of patients. So as you see, the patient 1, 2, and 3, we have them here. The patient with the ID number 1 is Alice. The second one is John Doe, and the third patient is going to be Maria Gonzalez. So let me insert these 3 patients, and then we're going to start inserting departments, because we cannot have a doctor without having a department. So let me create first the department information. So as you see, we have 2 departments here, cardiology and pediatrics. So the ID is 100 and 101. Does this make sense? These 2 elements inserted? So if you have questions, let me know. Now we have the table of doctors. In the table of doctors, we're going to insert, this is the Dr. Ray Taylor, Dr. Kim, and Dr. Patel. So as you see, they are part of the department 100, 101, and 100, as you see. So 2 doctors are from the department of cardiology, and 1 doctor is a pediatric doctor. Does this make sense? So let me run the instruction, and we have this information here. So if you want to check the data, you can click the tables. This is the first table, the table of patients, the table of departments, and the table of doctors. So we have 3 doctors. Now, let's go and start creating or setting up some appointments for the data that we're going to be querying. We're going to do some reports later. So the appointments are going to be the next ones. The first appointment has the ID 1000, and the patient is going to be the patient with the ID number 1. So if you don't remember who is this patient, is Alice Smith, and she is going to be attended by the doctor with the ID 10. So as you see, the doctor is Dr. Taylor. So this doctor is from the cardiology department. So the reason why she's going to have that appointment is because she needs to check up her heart. Okay. Now, this is the appointment 1001. It's the patient is the person that is called John Doe. He's going to be attended by Dr. Kim. So John Doe, it's going to be like, it's going to have a routine checkup. Imagine that he's a child, okay? He's a toddler because he's part of pediatric. Now we have the ID 1002, and this patient is Maria Gonzalez. She's going to be attended again by Dr. Taylor, and she has a chest pain. So it's part of a cardiology department. So let me, okay, let me run it again. Okay, now if I check up the appointments, guys, I see these elements. So as you see, if we click here, we can check the owners of the records. The patient ID number 1 is Alice Smith. The doctor with the ID number 10 is Dr. Taylor. Does this make sense, this part? Please send me a message for any feedback.
Yes.
Yeah, okay, it's making sense. Now, let's go for the next slide, because in this part, now we're going to do some reporting questions. So the first question is, how can we list all the departments, all the appointments with the patients and doctors' names? In this case, this question is going to require the join between the three tables: appointments, patients, and doctors. And we're going to bring all the elements that we have in common. So this is going to be an inner join between the three tables. Do you agree with this? So let me start creating this report for you. So the first table is going to be, in this case, the one that is the bridge table, the appointment. But it doesn't mean that this is the order. I mean, you can put the order that you want, because remember, this is like a multiplication. It doesn't matter the numbers or the order of the order. I mean, or the order of the products. You will have like the same result. Okay. So this is going to be renamed as the table letter A, and it's going to have an inner join between the table of doctors in this case, and we're going to set up the join between the A table with the doctor ID and the B table again with the doctor ID. Now we need to do an inner join again. We want to grab the name of the patient with the table of patients. This is going to be renamed as the letter C table on A patient ID, B, no, in this case is C, patient ID. So this is going to bring all the elements that we have in common. So let's bring the data. First, we're going to bring the ID of the appointment. It's important to note that. And then we're going to bring the patient name. So that's information that we have on the table C dot name. And we're going to bring the information from the doctor. And we have that information in the table D, I mean, table B. So we have the name. So as you see, the two columns have the same name. So as you see, name and name. So we can rename them, okay? As patient name, as doctor name. Because the definition of the tables, I mean, if you set up just the word name, and we can have a repeated column, it could create some confusion. So we're going to rename it, okay? So if we run the query, so as you see, Alice Smith is going to be attended by Dr. Taylor, John Doe is going to be attended by Dr. Kim, and Maria Gonzalez is going to be attended by Dr. Taylor. Does this make sense? Okay, well, this is the first problem, and put it here, problem number 1. Now let's try to solve the problem number 2. Okay, the problem number 2 is going to request find all the doctors and the department they are working in. So again, we're going to join two tables, the table of doctors and the table of departments. And this is going to be a relationship one to many. We have several departments. I mean, the one department can have several doctors. So in this case, we can use an inner join because we need to bring what is matching here, okay? So again, we can use an inner join too. So let's select the table of departments as the letter A, inner join with the table of doctors with the letter B. And now we need to set up how we're going to do the join between the two tables. So that's part of the on clause. And we need to select here the department ID, that is the primary key of the table of departments, between the foreign key, the doctors, that is again, the department ID, B dot department ID. That's how you create connections between foreign keys and primary keys, okay? Now, we need the name of the department here. So that's information that we have on letter A, or the table A, department name. And for the doctors, we have the information of the name of the doctor in the table B, B dot name. And we're going to rename this column as doctor name. Let's run the query. So as you see, we have Dr. Taylor, Dr. Kim, and Dr. Patel. This is the answer number 2. Let's go for the exercise number 3. Now, this exercise is going to require to show the name of each patient and the department they visited. So in this case, this is not the same as this one, okay? Because now we need to know the name of the department. With this query, we know the name of the doctor that is attending the appointment. But if we want to know the department that is part of the doctor, so we need to to interjoin the 4 tables. And we can copy this because it's like the same operation. And we're going to do now a new inner join with the table of departments. This will be renamed as the letter D. And we need to do the setup here. Now, what are we going to join here? We need to join the doctor's table and the department's table because they have a connection. Okay, so we need to set up here is that D doc department ID is going to be equal to the B table, that is the table of doctors, department ID. Now with this connection, we can know the name of the department that the doctor is part of. So that information, we grab it from the table D dot department name. So as you see here, we have the patient, the doctor who is attending the appointment, and the department of that doctor. Does this make sense? Now let's try to solve the problem number 4. And no, we're going to remove these 2 elements because they are a little bit more advanced. I don't want to give you a headache with these ones. Let me remove this part of the presentation. So guys, we have finished with these 3 questions, and I'm going to try to do some conclusions about it. Okay, so the conclusions are, so we can finish the lesson, is that joins are necessary if you want to create reports, if you want to get data. I mean, all the information that you are saving in the database, we need to do, we need to make decisions with that information someday. So if you want to make a decision, first you need to know how your data is looking like. So if you want to know how the data is looking like for a human, that's why we need joins. And joins are very similar to the operation of the intersection when you're doing sets operation. So as you see, you are grabbing all the elements that are in common with an intersection. The difference between a left join and an inner join is that you're going to bring all the elements that are in common, but at the same time, you're going to bring the 100% of elements that you have in the left tables. Remember that if you want to read a query, guys, we read the tables from left to right. So this is the first table, so that's the left table. And this is the right table because it's the second one. Now, the doctor is the left table for the patients, and the patient is the left table for the department. So you might need to know always that you need to read the information or read the query from left to right. So guys, if there are no more questions, I'm going to finish the lesson and you can continue working in the SQL Bolt assignment. If you have questions for the SQL Bolt assignment, let me know because I can help you. Does this make sense?
Yes.
Okay, guys, so maybe this exercise that I have done for you right now could help you with the assignment of SQL Bolt too. So good luck with that. Let me know if you need any support. Let me show you. Okay. Yes, I mean, this weekend I was playing around with an AI tool. Let me show it. LM, no, Google. Oh, this one, Notebook LM. Okay, and this is an AI that can help you to understand better a class. And if you have questions, imagine that you need a mentor or someone that can give you tutorings. This AI can help you with that. And it's going to help you with the code, with examples. And I mean, it's amazing. So what you can do is that you can create a new node. for example, in this case, this is a node that I created this weekend I called them week two. I mean, the week two notes. Okay. So I provided to this AI my presentations as a source, and I uploaded the videos, class videos to YouTube. Let me show it that I will be uploading the videos to here, and you will see that. I mean, if you want, you can share this URL to the AI app, and it's going to help you to create like a mentor for you. Let me show it. So, um, where is my channel? I mean, this is a channel that I created with the Codex account, and there is this option where I can see the videos. I have a playlist here. Yeah. So I created a playlist for you. If you want, you can watch the videos on YouTube, or you can go to the Drive. Um, so I upload the videos here. They are here in YouTube. What you need to do is that you need to share the URL of the video, and you can put it as part of source where you can add. I mean, that source from now on is going to be part of the knowledge of this AI. So if you want to ask a question, for example, um, um, what is a DML instruction? Okay, and this is going to help you to understand what is a DML, what is I mean, any question that you have from the class, you can do it to this AI. Does this make sense?
Yes.
Okay, and so let me explain it to you that I created a conversation that I have it here. Let me start sharing with audio. Let me stop and reshare. In this case with sound. So I created a podcast based on the content, guys. I mean, this AI created the podcast, and if you want to get like a summary of everything that we have learned in the past week, you just need to click.
Welcome to the deep dive. Today we're getting into something that, yeah, might sound a bit technical at first. How information gets organized and,
We're
well,
going to listen
managed
just
inside
like the
databases.
first minute, okay?
But honestly, stick with us. By the end of this, you'll feel like you've unlocked a kind of superpower. You'll understand the language behind almost everything you do online.
From ordering your coffee to, running a massive company's inventory system, it's everywhere.
Exactly. We're going to break down SQL structured query language. Specifically, we'll look at DML, that's data manipulation language, and DDL, data definition.
Okay, so I will. I mean, this is just a preview of the entire video of the entire audio, but this is some stuff that you can do with this AI tool. Does this make sense?
Yeah.
So how do we track our attendance? Okay, let me show you. This is the attendance. This is a question from Jill. Okay, so this is the attendance. I don't know if you have access to this file, but this is a file for, I mean, us as instructor, we are putting information for you guys. So Jill, this is the amount of participations that you have done here in class. Um, okay, so this AI tool is very important if you want to have like a tutor or a mentor based on the content of the class. And this is, I mean, this is, for example, what's the difference between ChatGPT? ChatGPT is going to give you answers very general. I'm not saying that ChatGPT is wrong, but sometimes we have a different content in class, and ChatGPT is giving you a different answer. And it doesn't mean that we have a wrong answer using ChatGPT, but in this case, this will be your mentor if you want. Okay, so it could be um, like a teacher assistant where you can set up a meeting, or instead of setting up a meeting without someone else, you can put the content here and you can ask questions, and you will see that that's going to give you the answers, and the answers that as an instructor could give you here inside of Codex. But you need to give the right content to the AI so you can do questions to it. Okay, does this make sense? I don't know if this give you a good, I mean, if this is a good idea for you. I really like it. I really like it because I mean, it creates mind probes here. For example, I mean, as you can see, this is like the database management, DML, DDL, SQL concept. And if you want, you can play around with the content. And it's very, I mean, I think it's very helpful if you want to create a summary of the content. And yeah, so this is the information that I want to give you right now. And let me explain you that in the Slack channel, I share it with you guys. Let me show it. Where's this? I share with you this audio that I was showing right now. It's like I mean, it's a podcast created based on the content of the class. And if you want to reinforce something, my recommendation is that you can start listening to this audio, and you will see that it's going to be very helpful. So, well, this was a quick announcement, and the other announcement is that we're going to have a free day this Friday due to the holiday that we have for July 4th. Okay, so let's continue working in the assignments, and let me know if you need any support.
Fernando,
Tell me, Tammy.
I do need help.
Okay, tell me, how can I help you? If you want, you can present.
Okay. So I'm able to get the, oh, I spelled that wrong. I'm
Okay,
able to
let
get
me
the
see.
role.
Exercise number 10. Okay, it is requested for each role, find the average number of years employed by the employees in that role. Years
I got the
employee.
years employed and I got the role, but it's not giving me,
Oh, okay. In this case, when you are grouping, this is a group by operation. You're going to group by the information. In this case, will be the role, because the years employed, it's the number. So in the number, you're going to do the calculation. So yeah, just roll by roll. And
oh,
that's the answer. Yeah. And the years employed, it's the number where you are doing the operation. So you don't need to group by that column, just
oh,
by
I guess
the, yeah.
I was overthinking it.
Yeah, but it was very easy, this one. But I mean, it's not so easy because grouping, it's a very important part of doing joins. It's very advanced. It's not so easy. You need to do some thinking, but from now on, you need to understand when you are doing some group operations, is because maybe you want to do an average, you want to do an addition. So in this case, the number that you're going to be adding or doing the average, it's not part of the grouping. Okay,
Okay. All right.
great. All right. The attendance cannot, I don't know where you can find the attendance. Let me know. I mean, let me ask the question to operation management deal, and I will give you an answer tomorrow, because I don't know if you have access to this file, but this is the file that I'm sharing to operation management so they can track your attendance. But let me know, I mean, let me ask them where you can know that information, okay, as a student. Tomorrow I will give you the answer. You have done a great job today. Thanks for your effort. So see you tomorrow.
Good night.
Good night.